Okay, this is a talk I've spent some time preparing, and I've even been back and edited it today. I'm going to just recommend two books first before I start the talk. There's a very short introduction, and then I can promise you it is solid astronomy or cosmology all the way. Two books. This one, A Brief History of Infinity by Brian Clegg. I think it's got quite an amusing title, A Brief History of Infinity. I thought that's quite funny. Nobody else does, but I do. And the other one, which is not so much about astronomy, but it does deal with it briefly, is mathematician Ian Stewart's book, Infinity, A Very Short Introduction. And I'm going to dedicate my talk to a mathematician, not an astronomer, Georg Cantor, who in the 19th century, the early 20th century, pioneered the study, if you like, of infinity. And for his pains, he was criticised by fellow astronomers who called him talking rubbish. And he ended up having two mental breakdowns, which is what happens if you think about infinity too much. Right, my grandchildren like to watch the Toy Story films, and there's a character there called Buzz Lightyear, who has this great saying, to infinity and beyond. Is that possible? Well, we're talking about astronomy, not mathematics. Famous quote by Tom Stoppard, eternity is a terrible thought, I mean, where's it all going to end? So let's define terms. We're talking about infinity, not eternity. Eternity relates to being outside time or time being never ending. Putting it simply, either something without beginning or end or outside time and space completely. Infinity refers to anything unlimited or unbounded, for example, a never-ending set of numbers, or space going on forever, or time going on forever. And you have to watch it when you look up anything about infinity on the internet, because there's some crazy people putting some crazy things on about the infinity of love and all this sort of stuff. So, and we don't want that. We want to stick with astronomy. The physicist Richard Feynman came out with this statement. He said, "It's my task to convince you not to turn away because you don't understand it. You see, my physics students don't understand it either. That's because I don't understand it. Nobody does." And that's very interesting, because that's in Brian Clegg's book on infinity. And then he tells you have to put in the quote in that Richard Feynman wasn't actually talking about infinity. Albert Einstein had a famous quote. He said, only two things are infinite, the universe and human stupidity, and I'm not sure about the former. Okay, so before we get involved in the astronomy, infinity comes into mathematics, as we've already mentioned. It comes into philosophy and theology, and I've tried to keep that out of my talk, and it comes into astronomy. I often use this quote in my talks. Douglas Adams has this famous quote, "Space is big, you just won't believe how vastly, hugely, mind-bogglingly big it is." I mean, you may think it's a long way down the road to the chemist, but that's just peanuts to space. So, the questions we're looking at. Is the universe finite? Is it infinite? Is it, to use Einstein's famous phrase, finite but unbounded? Or, and I'm going to suggest this, I'm teasing you with this, but I'm not the first person to say it. Can you say that in different ways the universe is both finite and infinite? Okay. Sorry, I've just got to move all your lovely faces. Ian Stewart comes out with this quote in his book. He says, virtually the only context in which scientists don't consider an infinite quantity to be a sign that their theories are wrong is cosmology. At various times, it's been entirely respectable to say that the age of the universe or its size is infinite. I'm going to ask you to bear with me for this talk, because Carl Sagan famously said, the cosmos is all there is, all there ever was, and all there ever will be. People have this idea now that maybe there may be parallel universes, and I'm hoping, if it's okay with you, to deal with that side of things, whether there's anything outside our universe, nothing, what is nothing, are there other universes, in a follow-up talk to this. Okay, so just assume for the moment that we're talking about this cosmos, this universe. The Greek astronomer, 2nd century astronomer Ptolemy, came up with this view of the universe. And I'm not going to go through it because I've done that before. Just to note three things. One is it's got the Earth, not the Sun, at the middle. When you've dealt with the 7 planets, which includes the Moon and the Sun, you've got the 3 starry realms, and you've got some Latin words on the outside. You've also got a double line. And what I'm going to show you is that that double line marks the outer extent of Ptolemy's idea of the universe. In other words, space and time are inside that double line, and outside is eternity. And I hate to tell you, but just have to tell you, not because I want to introduce theology, but just to make it clear, you'll see there are some Latin words on the outside. And those Latin words spell coelum imperium habitaculum Dei et omnium et electorum, which means fiery heaven, the dwelling of heaven, the dwelling of God and all the elect, which basically means Ptolemy's universe actually included heaven and the angels and God in it. If you had a modern cosmological scheme of everything, it's highly unlikely that you'd put heaven in it or God in it. Okay, so sorry about this long quote, but it's just to illustrate something. I've only got 2 long quotes in my talk. C.S. Lewis, the great writer, his last book, The Discarded Image, which actually tells you a lot about medieval cosmology, despite the subtitle of the book. He says you should go out, you must go out on a starry night and walk for about half an hour, trying to see the sky in terms of the old cosmology. And by that, he meant Ptolemy's scheme of the universe. Remember that you've got no absolute up and down. The Earth is really the center, really the lowest place. Movement to it from whatever direction is downward movement. The really important difference is that the medieval universe, while unimaginably large, was also unambiguously finite. So Ptolemy's view of the universe was that it was finite, okay? And then along came Copernicus with his different scheme of everything. He's got the sun now at the center, and he's got the planets, and he's got the, oh, okay, all right, okay, yeah, sorry. And then we've got the starry realm, and that's it. We've got a double line and nothing. In other words, Copernicus didn't see any need at all to include heaven or eternity or God. So in theory, his scheme of things could be finite. The universe could be finite or infinite, okay? By the way, a Greek Aristarchus of Samos had actually come up with a heliocentric model of the universe some, 14 centuries before Copernicus, 15 centuries, and that's why he's called the ancient Copernicus. And some people say it's even older. Here's a guy who's discovered a heliocentric system, and his friends are saying that's a wonderful idea, but can't we have something a bit more poetic, such as the Earth balanced on the back of a crocodile floating in a sea of mammoth's milk? Okay, so starting with Ptolemy, you've got a finite universe, and then the modern universe, based going back to Copernicus, is different. Just put this in because I just finished reading a book about him, but an Italian called Giordano Bruno actually had this idea, yes, the universe is definitely infinite. And I'm not going to give you all the quotes that he said, but his famous quote, he said, "I've declared infinite worlds to exist beside this our earth. It would not be worthy of God to manifest himself in less than an infinite universe." He believed the universe was infinite. He believed the stars in it was an infinite number. And he believed that the stars had planets. This is in 1580s, by the way, and that some of those planets were inhabited, okay? And about 40-50 years later than Bruno, who was burnt at the stake in 1600, a French scientist and mathematician and philosopher called Pascal came out with this very famous statement: "The eternal silence of these infinite spaces frightens me." So it looks like the idea of the universe being infinite in the 1600s was well underway. If anybody wants to read this up, and obviously I'm only referring briefly to the article, there's a very good article you can look up by Martinez and Martinez Arturo called "The Never-Ending Story of the Infinite Cosmos." And he says Copernicus laid the foundations for the idea that the universe is infinite. The English astronomer Thomas Digges publicized the idea in England. Bruno, as we've said, traveled over Europe publicizing the idea. And Sir Isaac Newton definitely believed in an infinite universe. Kepler did not believe in an infinite universe. It's slightly more complicated than that. Kepler was basically being agnostic about it. Kepler was a scientist and he thought, you can't prove it either way, so let's not sort of even think about it. But he did say this world of ours, the Earth, does not belong to an undifferentiated swarm of countless others. You'll notice I've missed out Galileo, and I'll come to him at the end. Isaac Newton, okay. One of these statements is wrong, but most of it's right. He believed that the universe is static, in other words, unchanging, and it's made up of an infinite number of stars that are scattered randomly throughout an infinite space. The universe is infinitely old and will exist forever without any major changes. This is called the steady state model. Well, Isaac Newton didn't call it that. That came a lot later, but he believed that the universe was infinite spatially and infinite temporally, okay? But then along came this guy, Heinrich Wilhelm Matthias Olbers, who came up with the famous Olbers paradox. I found out today, by the way, that Kepler had already thought this through, a century before, two before Olbers thought it through. He said, if you stand in an infinite forest of infinite extent, whichever way you look, you'll see a tree. By the same token, in the infinite universe, you must see a star, whichever direction you look in. And therefore, how can you have dark skies? There were three things, of course, Olbers didn't take into account. One is, as we know now, stars have a limited lifespan. Secondly, the light from a star travels at a finite speed. And thirdly, we can only see so far into space, and we live in an expanding universe. So we haven't got an infinite number of stars coming at us. So you could say, by the beginning of the 20th century, and here's a quote from a physicist called Lawrence M. Krauss. He said, as far as the scientific community in 1917 was concerned, the universe was static and eternal and consisted of a single galaxy, our Milky Way, surrounded by a vast, infinite, dark and empty space. This is, after all, what you would guess by looking at the night sky with your eyes, or even with a small telescope, and at the same time, there was no reason to think otherwise. You will notice, by the way, I've left Einstein out. That's deliberate, because I'm coming back to Einstein. Okay, that model of the universe was upset by these two people, as we know, the American astronomer Edwin Hubble and George Lemaitre, Belgian Catholic priest, and each of those threw a spanner in the works. Edwin Hubble, as we know, realized, and wasn't the only one, that there's not simply one galaxy, the Milky Way, but there are countless other galaxies. Here's a photograph of deep space, and the number of galaxies certainly in the millions, and probably more than that. George Lemaitre proposed the idea of the Big Bang, which suggested that it was originally called the hypothesis of the primeval atom, and it later became known, as we know, as a joke by Fred Hoyle, as the Big Bang, which implied that the universe had a definite beginning. And this is where it goes pear-shaped, and I want you to bear with me on this. Oh, before I do, by the way, I forgot to mention, another cosmological theory was proposed in 1949, the steady state theory, by Fred Hoyle and the Americans Thomas Gold and Herman Bondi. And the steady state theory is the idea that, again, the universe is spatially and temporally infinite. And basically, I think some of them were prepared to accept this expanding universe, but they didn't accept the Big Bang. They thought that was a load of rubbish. And here's where I think it goes wrong. Because if you look up a diagram of the history of the universe, and I looked up this one, now I know certain people who are so literally minded, they say, oh yes, I've got it, the Big Bang, yes, I can take that in. Yes, it's been growing ever since. So now at 13.7, now 13.8 billion years from the Big Bang, we now know the universe is rectangular, it's got hard edges, and it's finite. Well, we know that's wrong. We know it's a diagram, okay? But other diagrams are just as bad. So, okay, it's like a big balloon. It's spherically shaped, okay? And I even found this one. It's shaped like a donut, okay? And there is a thing on the internet about speculation about the shape of the universe. And it mentions the fact that the density of matter and energy in the universe determines the shape of the universe, since those things, matter and energy, can curve and distort space. There are three possible shapes for a 3D universe. We can't visualize them, but we can draw a 2D version of each of these shapes. So the one I would go for, if I had to say it had a shape, was the first one. Space, we know, curves so much that it wraps back on itself. So the universe has positive curvature and it's finite. It's a closed universe. And then we've got two other options. The universe has negative curvature and it's infinite. This is an open universe. Or thirdly, the universe has no curvature and it's infinite. It's a flat universe. But look at the little man on the left in the drawing, which goes back a few centuries. He's actually managed to go beyond the edge of the universe. And it looks like it's fairly cloudy beyond the edge of the universe. I didn't know that. I thought there was nothing. But anyway, in theory, so we can look back and see the shape of the universe. Just bear this thought in your head just for a minute. If the universe is, as Carl Sagan says, what we've got, and there is nothing else, then you can't go outside the universe. And in one sense, it's slightly unrealistic talking about the universe having a shape at all. A famous statement of Stephen Hawking, what lies north of the North Pole? Stephen Hawking wasn't talking about going north from the North Pole into space. He's saying on the Earth's surface, you can't go north of the North Pole. The North Pole is north, okay? And what I'm going to suggest is that the shape of the universe is a slightly meaningless question if you can't actually get outside it, okay? Right, let's bring it all together. Okay, the cosmological consensus. The universe had a beginning, the Big Bang. That's reasonably certain. And I've put reasonably certain because not everybody accepts it, but most people do. We have two members of our society, both physicists, who both told me privately they don't believe in the Big Bang. And one of them stood up in a meeting a year ago and said that at Leeds University. Okay, so I'll put it's reasonably certain. I believe in the Big Bang, but okay, not everybody does. We know it's expanding. We can prove that it's expanding now. We also know it's very big, but does very big mean infinite? That's certain. And we can also estimate what we can see, the observable universe, which up to last week was calculated as 93.016 billion light years. That's certain. But is the universe itself finite or infinite? And I'm saying the jury is out. I thought I'd consult this astronomical expert, Donald Rumsfeld, who died a couple of months ago, who came out with this statement: there are known knowns. These are things that we know that we know. There are unknown unknowns. That is to say, there are things that we know we don't know. But there are also unknown unknowns. There are things we don't know we don't know. I don't know if that helps or confuses you, but I thought I'd put it in. I thought it was time you had a bit of humour in the talk. Okay, conclusion. I'm coming towards the end. I'll accept that the universe is finite but unbounded, which means it has a finite volume, a specific number of galaxies, no three-dimensional edge, okay? But, and I saw this on one website from Astronomy Now magazine, I think, somebody saying, well, the universe itself isn't infinite. We only know it's the observable part that's finite. So I'm begging the question here, can a single finite, but I should say unbounded, a misprint there, unbounded universe be the same thing as an infinite universe? Now, this is counterintuitive, but it's like Copernicus' theory when it was first propounded. That was counterintuitive. Set theory in mathematics, Georg Cantor realized it could have infinite sets of numbers with a smaller and a greater number of numbers in each set, okay? Things in quantum physics are counterintuitive, and directly relevant to what I'm talking about is something in mathematics called Gabriel's horn, which is this shape, which is based on a mathematical calculation, function of x equals 1 divided by x. You can go draw a graph from it, and you can get this three-dimensional object. And you can show that the horn has finite volume, right? In other words, as you go to infinity on the right, it'll get smaller and smaller, so it'll end up having no volume at all. But if you use the mathematical equation 4 lines up from the bottom, you can see and prove that the horn has infinite surface area. So in some mathematics books, it will tell you that the same object, Gabriel's horn, can be filled with paint, but it cannot be painted. So are you confused? Okay, thought you'd like that cartoon. So Brian Clegg says, since Roger Bacon's time, our idea of the size of the universe has fluctuated between true infinity, as Newton believed it to be, and the limits of measurement of the most distant cosmic objects. This latter view, which is the majority view at the moment, still prompts the question of what happens at the edge. If space is not infinite, what is beyond the boundary of the universe? And I was going to say, I've got another talk dealing with that, follow-up talk to this one. The most popular suggestion is that there is no edge in the sense that we are familiar with. So as you reach the limits of the universe, space is so folded in on itself through some unspecified other dimension that you effectively re-enter the universe at the far side. Put simply, it means if you travel in what you think is a straight line forever and ever and ever, you'll just keep going forever and ever and ever. Okay. And my favorite, one of my heroes, Marcus Aurelius, said, well, everything we hear is an opinion, not a fact. Everything we see is a perspective, not the truth. And this famous, very famous optical illusion, which from one side looks like you've got 4 pieces of wood, and from the other, you've got 3. And yet it's the same thing we're looking at. So to finish off, if the universe is all there is, I'm saying it should be finite because it's expanding. Now, there might be a mathematician out there that tells me that infinity can expand, but I think of something that's expanding as being finite. However, it's infinite in practice if there's no edge to ever reach. So can you say the universe is both finite and infinite? All right. And Ian Stewart says, if the universe is infinite, you can never verify that scientifically, okay? But you can infer it, just as you can infer the temperature of the sun without sending a scientist up there with a temperature to go and take the temperature, just as you can infer the Big Bang without winding the clock back of the universe, okay? But as Ian Stewart says, it's very hard to see how we could then distinguish something as being genuinely infinite from just saying it's very, very big. So whatever you decide, the jury's out. And I thought I would defer to somebody greater than me, Galileo, who said, don't you know that it's as yet undecided? And I believe that it will ever be so for human knowledge, whether the universe is finite or, on the contrary, infinite. And on that note, I quote from a video that I saw today about, is the universe finite or infinite? And it said at the very end, the final answer will always elude us. And on that point, say thank you very much for listening.
Right. Thank you, David.
How do I get rid of it now, Steve?
Well, you can't get rid of it.
Oh, stop share. Yeah, they are.
Stop share, yeah.
Thank you.
Okay. What do we want to do? Do we want to have a short break?
Well, does anybody have any burning questions to ask?
Sorry, sorry.
Just perhaps 2 questions. Would anyone like to make use of that time?
I think Ray's put his hand up.
No. I was just appreciating David's contribution, that was all.
Yeah.
Thank you. Yeah. It's very funny because I've done a talk on infinity, and people, you say, oh, how long is it going to last? Ha ha ha, very funny, talk on infinity. And then I've got a follow-up talk on nothing, so I say I'm doing a talk on nothing. People say, oh, well, I'm not bothering coming to it then, you know. You can't win.
Right.
Dave.
Yes, hi.
Hello, Dave.
Hiya, Julie.
There was, as I mentioned earlier, a Sky at Night program. I think it was from Chelmsford or somewhere, some sort of venue, and it was like an open evening with some panelists on. They had that Maggie Adrin Pocock and Chris Lintop and a few other scientists. They had a cosmologist on who was asked about something relating to your talk about, you know, is a lad from a local school, which one of these panelists came from, asked the question, are there other universes?
Yes.
And this woman cosmologist, she said, well, basically, we know that nothing doesn't exist in the universe, even if it looks as if there's nothing there. There's this quantum froth and foam going on with virtual particles flicking in and out of existence in, sort of incredibly small amounts of time. And some of these, apparently, she said, can be baby universes that just sort of like vanish in a puff of logic or whatever it is, or quantum froth. But there are others which will just expand like our universe. So the theory is that our universe came from a baby universe, which then through inflation just expanded into the enormity of what we now see, and that this doesn't, most of the time this doesn't happen. But she did say that just because we happen to be in this universe, so it obviously happened here, doesn't mean to say it didn't happen again. Well, a very brief sort of second or so later to another baby universe, so that there are possibly an infinity of these expanding universes from tiny little bubbles that emerge out of virtually nothing. I just wondered what you thought about that.
Well, funnily enough, as I told you, the following talk that I'm doing after this, which I hope to do, I'm actually dealing with that whole thing about parallel universes, whatever. I'm including that in my talk. But it's very interesting that Chris Lintott seemed to be entertaining the idea that there could be parallel universes, because it all comes back to this fact that everything seems to be so fine-tuned in this universe for life such as we are to exist. So that's either an accident or it's coincidence, or if you happen to be a believer of some kind, you say, well, God designed it that way, but I mean, I can understand if not you, but whoever it is, decides to cancel God out, take God out of the equation, then you've got to say, as Owen Gingerich, who's a retired professor of astronomy at Harvard, says, it's either an amazing coincidence, or you just have to say, well, that's just the way it is. We just happen to live in a universe that is suited for our purposes. As to whether there are universes outside this one, it's almost like the same question about infinity and finitude. And I was reading today, the reason that Galileo and Kepler would not go along with the idea of the universe being infinite was not because they thought it was wrong. They thought this is speculative. If we're dealing with science and mathematics, you can't prove it either way, right? So Galileo didn't want to be drawn on it. And also Galileo was also very much aware that Giordano Bruno had been burnt at the stake. And Galileo wasn't too happy about upsetting the Inquisition, so he tended to keep his thoughts to himself. And it said that Kepler was a prudent physicist. Again, he thought that everything should be resolved through mathematics. So anything to do with parallel universes is speculative. And in fact, you could believe one thing, I could believe another, and neither of us is right, or both of us are right, because we can't prove it either way. And to me, I think my own opinion is, which I've discussed quite a bit with Chris, your brother, is that science tends, when it goes down that road, to be going into science fiction rather than science, because science to me is something that's evidence-based. And if you can't ever get the evidence, and there's no chance you can, because we only live so many years, and also we can only travel so far in space, and the likelihood that we'll ever be able to go beyond a certain distance in space is highly unlikely. So to me, that's very interesting, and it's science fiction stories, but I don't think that's...
Well, but isn't there, sorry to interrupt you, but isn't there actually hard and fast evidence that a single photon can be sent down two different slots both at the same time, which seems to suggest that it travels through two different universes at the same time.
No,
and this experiment is not a one-off, it's been repeated
Yes.
time and time again by all sorts of different physics laboratories. It's not, you know,
Yeah.
There's something odd going on at the quantum level that we just haven't really got to grips with and understood.
Yeah. I agree with that. And I mean, I've mentioned it in talks I've done when I was doing my U3A classes and things about that, things in quantum physics. The difficulty there is whether you can say that because something happens at the subatomic level, at the micro level, it also happens at the macro level. And we know that certain things can happen, like, for example, particles at the subatomic level, according to an article that was in New Scientist a year or two ago, can go backwards in time. I don't think there's evidence that human beings can go backwards in time, right? So I think until such time as we, as you say, we get a grip on uniting or bringing together the findings of quantum physics and science at a larger level, then perhaps we can tie it all up. But I think at the moment, I think it's still atomic at the subatomic level, not at our level. That's my opinion, by the way. I'm not saying it's right.
Which, of course, is what Einstein was trying to do, but he never managed it in his lifetime, did he?
Yes, indeed.
Yeah.